This is going to be the board that tells us, or tells you guys, our process of how we got to doing the challenges that we are doing.
Okay.
So first, this is what we, Sarah and Colin did to decide which were going to be the best challenges for us to do, based on, well, you guys can say that.
Alright, so we decided to do this based on, we looked at all the points and where they were on relation to each other, so like to make sure they weren't like one over here and one over here, they were close.
Okay.
And so then we devised programs and we color coded them.
Okay.
So this was our original thing that we wanted to do. So we went out, like the first program, we went out and did the plane and the tsunami, and we came back, and then we went and did this and put the two trucks down here, and then we did that. And we came back, and then we did get the pets and the person on the motorcycle.
Okay.
And then we went over obstacles.
And that would have gotten us 252 points.
That's something like that.
Okay, and then next, after that,
After that, last year our first robot went pretty crazy, so we wanted to try to take that down. So with our NXT earlier, we did something kind of like this to scale, to find which one matches best. Each of these colors are a different layer.
Okay.
so we wanted two motors that were 12 each other.
Oh,
At
okay.
25, 50, 75, and 100 pounds.
Gotcha.
Alright, and then after that, we made our robot design. It's compact, and it's sturdy, and it only has one attachment for a very good reason. It does all of the things we needed it to do, and it's better that way because then you don't have to fumble with it. So a lot of teams have a bunch of attachments, and we only have one because it does everything we need it to do. And we never have to take it off or put it on. It's just always there. So it's very helpful that we only have one.
Yeah, it's amazing.
And so that's what our robot looks like. We decided to have treads because we're originally going to do the last challenge that goes all over those, but we decided to cut that because there was lots of other things like the tree that we could do for the same amount of points or more in less time. And the treads have gear right here that helps to pivot, and we got that design from a Lego UV3 like starter robot kind of thing. So after that, we kept revising it quite a few times, but then we started making these My Blocks that are very helpful, which are on this board behind it. So we're going to show you task 2, which is the second program we run. It has all of these My Blocks in it, and it has 4 different ones. There's My Blocks that are inside of My Blocks, like right there, but mainly we're just going to show you the ones that you can see that we use. So, to base start.
So base start we use for all of our programs except for one. Basically, it allows the ultrasonic sensor to follow the wall and keep it at a good distance, and then the light sensor senses the black, which is what that does. It senses the black line at the end, stops, and then it will turn the right direction that we need it to go. That way we don't, because like last year, we'd set it down and we just have to use it by our eye and it'd be off. So this year we don't have to be as precise,
Because it will align itself for us. And then for proportional pivot,
So it turns the robot a set of number of degrees, and it uses a proportional algorithm to slow down the robot as it reaches the target degrees. And if it goes over, it'll turn back. And the positive degrees turns it right, and negative turns it left.
What do you mean by proportional programming?
proportional programming is how it will align itself on a certain degree. The further away you are from your degree, the faster it will turn to it, and the slower you are, or like if you're really close to a degree, it will slowly get to it so it doesn't overshoot. And if it does, it will come back to where it needs to be.
And this works because we've got the gyro sensor.
Oh,
Well, it can also work with motors and stuff too.
Yeah, not quite that.
And the game will make it stop on a certain block instead of just going like this all day long, trying to decide on a number. And then for the accurate move, is that 80?
Oh, anyway, this transfers. What is this? then decides if it has to go forward or backward, depending if it's true or false.
Okay.
And then it will complete this loop until it goes that amount of rotations. And then for the gyro straight, which we use quite a bit, it uses the gyro sensor. When we clear it, it will make a virtual line anywhere, and then it will use our proportional algorithm to follow it for the set amount of distance. So the loop will keep looping until it's gone the certain amount, and it will just keep aligning itself on the 0 mark. So it's like it's following a virtual line that it can make anywhere.
Okay.
It's used for following a line, or it can be rotating on a line.
It's following a line that the gyro sensor creates.
Okay.
And then here, so that's what that loop does, and then in this loop, we'll rotate it back to the 0, because sometimes when it stops, it kind of stops like that, even though it was like that a second ago. So then it realigns it up to 0.
Okay.
So that's what our MyBlocks do that are inside task 2. There's other MyBlocks inside MyBlocks, like bounded and absolute bounded, and stuff like that, but those are just, there's a lot that we have. So those are just inside the ones that we normally use. So those are 4, that's our 4th step, which are MyBlocks. And they have different inputs, so we can customize them even after we plan. And so 5, we have all of our tasks.
And the sensors program.
So our sensors program tells us if any of our sensors are going crazy.
Like our gyro sensor will go crazy.
It likes to
Sometimes
randomly
it likes
count
to randomly count down or up. Sometimes slow, but very quickly at others.
So then it will make us overturn or underturn. And then task 1, what does task 1 do?
Task 1, okay, so task 1 goes out and gets the plane and a tsunami, so we did that just like we wanted to over there. And then it goes to get the ambulance down here, and then it comes back and gets the guide, and
And
then
that
comes
comes
back
back
here.
to base.
Task 2?
And then,
Okay, so task 2, it goes out, uses base start, turns, goes out, grabs the truck, brings it down there, and then it just comes straight back.
Task 3?
task 3, we go out and get the, we knock over the pets first, and then we hit the tree, and then it grabs the pets and turns, and brings them back to the
And
thing.
finally task 4,
Task-
you want to explain now?
Task 4 grabs everything that we got out here, including the mail and all the supplies. We use these 2 buildings for trays. We carry them all, and then we carry them all over to the red zone. And that's where most of our points are.
We had a happy accident.
Yeah.
The sign, it's like,
It's in the way,
some,
huh?
no, it'll like sometimes pop up and stay up
it'll hit
on
that.
its own.
It'll come
So we're
on
gonna
by
show you-
accident and do that
Okay.
kind of.
Alright, and then
and
now
then
we're
it'll
going to
hit
show
the
you a
generator.
demo of our gyro straight program, and we're going to show you the 2.
And we eliminated this course because we figured out we could get like 3 times the amount of points carrying all the people.
Yes, take what you need up, that's fine. It's
And
fine.
also, unplugging all of the sensors makes us have extra accuracy every time we turn it off. So that's what I'm doing now before I turn it
It's
on.
gonna take a while. The EV3 takes a long time to upload.
I was lucky to have EV3.
Yeah, a fundraiser. We got a lot of money with our fundraiser.
Good job.
And we are
Only it's gonna take
helping
a while.
other people do our fundraisers so
Let's
that
see,
they can.
your ultrasonic sensor in there, this is a lower wall
We
table.
have-
Yeah,
Does
we
that cause a
built,
problem?
it
Yeah,
did,
last year.
so we built a
That
wall
down
last.
Well, last time I got you.
Yeah,
Our table at
last
home is
year.
right here.
Yeah, our table at home was a 2x4, so we put the 2x3 next to it.
Yeah.
Is it even loaded on here, guys?
It's taking a while. We
We're
better
just gonna
switch
do task 2.
on how long it takes to turn on and off.
Well, Trevor, since this is the actual map, we could just do full
Alright.
program.
We created gyro straight because of the truck. The truck was randomly making the robot go the wrong direction because of the wheels. So it would randomly go different ways on the board. So the gyro straight muscles it along because the motors will think they're going straight, but they're not.
Trevor, do you just want to do task 2? Just to show them how we use the base star.
It's not, so just task 2.
Okay, we're just gonna do task 2.
Alright.
Program.
Alright, perfect.
No, that'll be different.
Oh, yeah.
Trevor, shouldn't this be like on the edge of the map since this map doesn't go all the way? No, it
Yeah,
shouldn't be right
you
there.
wanna
It should
do
be-
it- you
Yeah,
wanna do it wherever.
so I'll hold it right there.
Okay, so I'll stop it while it's in action, so you can like, pause it for a second.
That's not good. Right, right.
So right
So
now
this
it's
is our
lining
base
up on the
start.
lawn.
This is our,
So right here is capturing the truck. This is the beginning of the gyro.
straight. See, you can sort of see it turn
Here's proportional pivot and more gyro straight. And then it pushes it back in so it's out of the airplane wire. And it comes back.
Accurate move. Every single turn that we use is always.
Oh, it was supposed to read this wall, but the different lighting in here, it read that line instead of this line. So it would have done that and gone into base. But since there's a light right above it and it's not in the gym, it messed up.
Understood. So, how did you guys decide on the design? I mean, what led you to this particular design?
We wanted to have
based
it.
on- Based on the board. It was all based on the board.
We wanted to have it simple because we figured if we could make one attachment do everything, we'd save quite a lot of time instead of
Yes.
having to come in base and switch it all out.
And we did.
And the compact design is nice because we need to get under the wire and it makes it a lot sturdier. So if you were to drop it, I bet only a couple of pieces would either break or
I
just
wouldn't
come
recommend
apart.
dropping it.
Yeah, we're dropping it, but if you get it with the shadow.
Don't worry.
Alright, so,
And another advantage for having it being compact is it can maneuver through small areas.
so I
And
see
the
the
only-
sonic sensors.
The
and-
only setback that we have on it is the batteries are really hard to get to.
And we have to replace them a lot because new batteries make our robot more accurate. So next year, we would make our robot easier to get the batteries. Yeah.
Or get the rechargeable battery.
So you have a sonic sensor, and I see a light sensor. What other sensors do you guys have?
We have the gyro sensor.
We
Gyro,
have the
touch,
gyro. we don't-
light and ultrasonic.
Oh, we
But
don't
the touch
use.
we don't use. We planned on using it for the sign.
But it didn't?
Yes.
Okay.
Yeah, because we didn't see it.
Yeah, but it is there for a kind of a bar to push.
Yes.
And it has a little bit of resistance, which helps because it's a spring.
Okay, very
Yes.
nice. Well, guys,
Oh, and there's one more. It's the motor rotation sensor in the motors.
Oh, in the motors. Okay. Okay. Part of it, right?
Yeah.
So
Right.
last
Nice.
in qualifier, we got 389 points. Our top score would have been 392 points. We lost 3 points because something fell out of the truck. And between qualifier and now, we added 30 points by doing the tree, so now our top score is 422.
well, good luck, guys.
Well, how it does the tree is it sort of hits the top.
It just whacks it out.
Yeah.
Like,
Okay,
if it works, it works.
There.
all